In this series, we're going to deep dive into the tools that Django gives you, the developer, in order to integrate your applications with relational databases. Now, Django as a framework is designed to work with relational databases. It's not a requirement for using the framework, but the framework provides you with all of these excellent tools in order to query and create data from that database and to the database. And through the ORM, it allows you to do so in an object-oriented Pythonic manner. So in this introductory video, we're going to dive into what a database is, and we'll have a quick look at some of the common database systems out there. We're also going to look at the anatomy of a database, which contains tables, columns, rows, and data types. After that, we're going to cover what primary keys are and also what foreign keys are. And finally, we'll end the video with a quick look at SQL, and that's the querying language that you can use in a database in order to get data from the database tables and also to create, update, and delete records. Now, throughout this series, we want to cover a multitude of topics, including how to define Django models, how to create data in the database with these models, and how to query and filter records based on certain conditions in your application. We're also going to look at how you can create foreign keys and many-to-many relations in your Django applications. And then we're going to move on to some more advanced topics such as how to aggregate and group your data, how to use subqueries and conditional expressions, and also how to use database transactions in your Django code. After that, if there's sufficient interest, we're going to cover topics such as database indexing for improving the efficiency of your code. We'll cover database constraints that allow you to constrain the values that can be input into a column. And we'll also look at Django's content types framework that allows you to create generic foreign keys between different models. And we'll have a look at GeoDjango as well for those that are creating geographical applications with Django. And if there's anything you'd like to see in this series, please let me know in the comments. This is kind of an open book, so anything that you want to see, I will be able to add that later on. But for now, we're going to get started with this introduction to database systems. Now, I have the Django documentation open here. It's a section on databases, and you can see that Django officially supports the following 5 databases. We have PostgreSQL and MariaDB. We also have MySQL and Oracle. And finally, we have SQLite, which is a little bit different from the others. That's a file-based database. And SQLite is the easiest system to get up and running with. It's just a file. We're going to use that for most of the series, as well as using PostgreSQL when we need to. Now, all of these are database systems, but they all do roughly the same thing. They store data in as efficient a manner as possible, and they allow you to query the database tables in order to get the data you need from those database tables into your applications. Now, a database can be thought of as a collection of tables, and these tables have rows and columns. I'm going to go to Wikipedia and we're going to look at this page here on rows in a database, and you can see this columnar structure at the bottom here where we have a table, and that table consists of columns, and each column represents a piece of information that you want to store about a particular thing. And as well as the columns, each table has rows as well, and each row in the table represents an observation or a measurement for a particular entity. We're going to see examples very soon of a concrete database table and the rows and columns that might be present in such tables. Now, as I said, we're going to use SQLite throughout most of this tutorial. I'm going to go to the page for SQLite and we're going to read a little bit about that here. And we can see that SQLite is a C language library that implements a small, fast, self-contained, highly reliable and full-featured SQL database engine. And interestingly, SQLite is actually the most used database engine in the world, and that's largely because it's built into all mobile phones and also most computers. And when you create a Django application using the migrate command that we're going to see a little bit later, what that will do by default is create a SQLite file within your local directory. Now, what I'm going to do is go to VS Code for a moment, and I'm going to minimize all of these files here. You can see this database file, db.sqlite3. That is a SQLite database. And when you create a Django project, what happens is you get given a file called settings.py. And if we scroll down, one of the settings that you have is this one here. It's called databases. And if your Django application is going to integrate with a database, you need to set this setting here. And it's a dictionary, and you set a key for each database you need to connect to. So in this case, we have a database called default. And what we do is we specify an engine for the database. And in this case, as you can see, it's a SQLite 3 engine. And in the case of a SQLite database, we also give it a name, and that's basically the name of the file. So you can see it's called db.sqlite3, which matches what we have on the left-hand sidebar. Now, this code is given to you when you start a Django project, but if you're using a different configuration, you will need to change this. We're going to see an example of that later in the series. but this is the minimal configuration that works out of the box when you start a Django project. Now, because we're going to use SQLite, I'm going to go back to the browser here, and what we're going to do is go to this page here. And this page is for DB browser for SQLite, and it contains a graphical user interface that allows you to take that file and actually visually see the tables and the rows and the data that's in those rows. So I would recommend, if you're planning to follow along with this series, to download the database browser for SQLite, and then we can actually inspect the tables that we have and inspect the data that's in them. Now, I already have this open, and you can see that here. What you need to do is open a database. So you can click this tab at the top here, and when you do that, you can select the SQLite 3 file that you have in your Django project, and then you can open that database. And if you go to the tab for database structure, you can see a list of all of the tables that you have in your Django project. Now, 2 of the tables we're going to work with throughout this series are these 2 here. Firstly, this is the core restaurant table, and that contains data on a restaurant. So let's imagine we're building a system that keeps track of data on restaurants, including user ratings, and we have a rating table here as well to store the ratings that users give to these restaurants. So we have this system, and the restaurant table is where we're going to start looking to see what's in that table. So what we can do is right click and go to browse table, and you can see you get back that columnar structure with rows and columns. So this is the restaurant table. It's one of many tables in our database, and you can see we have 14 rows of data, so 14 measurements in this table, and we also have a number of columns here, and each column has a title, for example the name of the restaurant, and we also have columns for the restaurant's website, the date the restaurant opened, the restaurant type, for example IT for Italian, and we also have at the end here a latitude and a longitude for the restaurant, and that tracks the location of the restaurant. We're going to use that much later in this series in order to use GeoDjango and plot points on a map, as well as figure out where the nearest restaurant to a given location is. So just to hammer home the point here, we have rows, as you can see highlighted. They go from left to right and they store data on a given restaurant, and we also have columns, as you can see, from top to bottom, and that's a particular measurement for every single restaurant in the data, for example the name of the restaurant. Now, as well as names, columns also have a data type. If we go back to the database structure and right click the restaurant table, we can go to modify table here, and that will bring up this pop-up. Now you can see a tab for fields here. That's basically a synonym for columns, and you can see the names of all of these columns in our table, and each column is associated with a type, and that could be an integer field. For example, the ID is an integer. We also have a varchar field, similar to a string in a programming language, and we also have a date field for the date opened. That tracks when the restaurant was opened, so that's stored as a date data type. And at the bottom, with the latitude and longitude, we are storing these with a data type of real, so it's a real number. And at the right of that, we can see some constraints. We're going to look more at that later in the series, but let's highlight this one here called PK. And only one of these columns has a tick for the PK, and that's the ID. Now, what is the PK? It stands for primary key. And the column that is a primary key in a database table is the column whose value will uniquely identify the row. So the primary key must be unique. You cannot have a duplicate value in another row for that primary key. And very commonly in a database, you will have your primary key be set to an ID field that is auto-incrementing, and that's what the AI tab here is. And auto-incrementing means that when you add a new record to this table, it's going to take the maximum ID that was added last time, and it's going to add 1 to that. So basically automatically incrementing it each time a new record is added. Now, you don't need to use an auto-incrementing ID. For example, if you have a table of citizens in the USA, you could have a social security number as the primary key here, because that uniquely identifies a citizen. The important point though is that a primary key must be unique for each row in the database, and so when you query a table for a given primary key, it will only return 1 row. Now, you can have a primary key over multiple columns. That's called a composite primary key. For example, in a restaurant dataset, you could imagine that the name of the restaurant combined with the latitude and longitude might uniquely identify the restaurant, since you can't have 2 restaurants at the same location with the same name, presumably. But when you're working with databases, typically you want to use a minimal key. For example, a key on 1 column if it's possible. And that's the way this system is set up. We have a primary key on the ID column, and that's all we need. Now, keys are very important to understand in database systems, because in a relational database, keys are used to join one table with other tables in your database. And when you have a column in a table that joins that table to the primary key of another table, that column is called a foreign key to the other table. We're going to see an example of foreign keys now. I'm going to go to the core rating table and we're going to browse that table. And you can see we have two columns here for the restaurant ID and the user ID. Now, as it turns out, these are foreign keys to the primary key of other tables. For example, the user ID of 1, that is a foreign key that ties this given rating to the user whose ID is 1. So let's read the first row of this table. We have an ID of 64, we have the restaurant ID of 45 and the user ID of 1. And whoever this user is with the ID of 1, they've given restaurant number 45 a rating of 4 out of 5 stars. So we can go to the Django user table here and we can see there's one user in this database, only one row, so one user. And that has the ID of 1, and this is the given user who has given that restaurant a rating of 4 stars. So that column in the rating table that we've seen here, the user ID column, that's called a foreign key because the value in that refers to the primary key of another table. And you can use this knowledge to join the two tables together to find out which user has actually given this rating of 4 stars. And we can look at foreign keys in the structure of the database. If we right click the table and go to modify table, you can see the fields or the columns here, and we're going to click the user ID. And if we go to the right hand side, you can see there's a tab for foreign keys. And you can see that this column is a foreign key to the auth user table's ID column. So that's the important thing to know about foreign keys. The value will link one table to another table, and it allows you to perform these joins in your SQL queries in order to join up the records and get the right data. So you might be asking, why do we need foreign keys in a database? Why do we not just store everything in one table? And the reason for that, if we go back to the rating here and we browse this table, you can see that the user ID is here and it's got a user ID of 1. And you can see in this dummy data that every single user has that ID of 1. Now imagine that for every single row in this rating table, we also had to store all of the user details rather than just storing the foreign key number. Storing a number such as 1 does not take up a lot of space here, and you can see we've got 30 rows in this table, so we just need to store 30 of the number 1. If instead we were storing all of the user information in this table rather than using a foreign key, if we go to the user table, you can see we would also need to store all of this data such as the last login time, the username, the last name and the email address, and so on. And that would take up a lot more room rather than just storing a reference to the foreign key number. So it's much more efficient to store a foreign key rather than to duplicate all of that data in the table. And this was a particular concern years ago when space was at a premium, but nowadays we do have a lot of space, but it's still a good practice to use foreign keys and not to duplicate data unnecessarily. And everything we said there, it also applies if we go back to the rating table to the restaurant ID, because that's a foreign key to a restaurant. For example, restaurant 45, if we go to the restaurant table, you can see that refers to this Italian restaurant here. Now in a second we're going to see how to write SQL queries to get the data we need out of these tables, but what I want to do just before I do that is go back to the statements here in the modify table. Now you can see at the bottom we have this create table SQL statement. And this is our first look at SQL in this tutorial. You can see the create table statement, and it creates a table with this name, core restaurant, and that matches what we see on the left hand side. So when you create a table using an SQL query, we give the table a name, and then we open some brackets and we specify all of the columns we want in that table, along with the data types such as integer and any constraints that we want to apply to those columns, such as a not null constraint. And you can also see when we create the table with this SQL expression, we have a primary key statement here that specifies that the primary key in this table will be the ID column, and that will auto increment. So that's how we create a primary key with our SQL in a create table statement. And we can also see how to create a foreign key if we go to the core rating table and click modify table here. I'm going to make this a little bit larger, and we can see we have another create table statement. Again, the name of the table is set correctly to this time core rating, and again we're setting the primary key to the ID column. Just below that you can see we're using the foreign key expression to create a foreign key on the user ID column, and we're telling the database that this user ID column, it references this table's ID column, so the auth user table's ID column. And we do the same with the restaurant ID. We're creating a foreign key to the restaurant table's ID column. So SQL allows you to create tables using a create table statement. We're now going to see how to actually use SQL to query the data in a database and get back the data that we want. And that might be a subset of all of the rows, it might be a subset of columns. We're going to see how to do that now with SQL. So let's close this tab. So at this point we should have built up a picture of how databases are structured. We should know what a table is, and that a table is comprised of rows and columns. We know that columns have a data type, and we also know that rows are identified by primary keys. And finally, we know that foreign keys are used to join two tables together, and that's done with a reference from the child table to the primary key of the parent table. And foreign keys are used to help you reduce redundancy in your data. So let's get started now on using SQL to query data from these database tables. Let's start with this restaurant table. If we browse the table, you can see some of the data. And you can see a tab just above here called Execute SQL. So if we go to that, we can execute SQL statements. And that's done with a select statement when you want to retrieve data. So we can select all of the fields from the table core restaurant. And when we execute that, we get back all of the rows from this table, and we also get back all of the columns as well. So it's giving us all of the data in the core restaurant database table, but we can filter that down, and that's done using a where clause in the select expression. So let's say we only wanted to get restaurants that were Italian restaurants. You can see there's a restaurant type column, and there are values in that, and you can see IT for Italian restaurants. So what we can do in the where expression is we can say we want to restrict the results to only those where the restaurant type is equal to Italian restaurants. And if we execute that query, we get back a subset of the rows, and you can see that all of the restaurant types are Italian for these rows. So that's how we can take a database table full of data and we can get back only the results we need. In this case, we only want the Italian restaurants that are represented in this data. And these are the three most important operators in SQL. We have a select that tells us that we want to select data from a particular table. We have the from clause that tells us which table or tables to do that selection from. And potentially we might have the where statement, and that tells the database system that we want to filter down the rows based on the condition or conditions that come after the where keyword. And if you are familiar with Django already, you might use model.objects.filter or model.objects.exclude. Under the hood, that is actually building up a where clause based on the filter conditions that you give to the Django ORM. We're going to see much more of that later in this series. Now let's show an example of multiple conditions. We might want to get not just Italian restaurants, but also Chinese restaurants from this data. So instead of just saying restaurant type equals IT, we can also use an OR expression, and we can say restaurant type could also be equal to CH, which stands for Chinese. If we execute this statement, we get back more results this time, more rows. And that's because we now not only have Italian restaurants, we also have 3 Chinese restaurants as well. So in your where clause, you can build up multiple conditions. In this case, we are looking at the restaurant type column, and we are filtering to restaurant types that are Italian or Chinese. Now when you have an OR clause and you're checking for values over the same column, we can use a different syntax. So I'm going to remove this code here, and we're going to check when the restaurant type is in, and then in brackets we can specify all the values we want to check. In our case, Italian and Chinese. So we have a different syntax here. If we execute this, we get back the same results where the restaurant type is Italian or Chinese, but instead of 2 conditions separated by an OR statement, we can use the in expression in SQL, and in brackets after that you can put as many values as you want, and it's going to return all rows that match any one of those values. So that's just an alternative way of specifying the condition in this where clause. We can use the in expression, or we can use multiple and or and not operators, and in doing so you can build up complex filters for your database tables. Now if we go back to browse this data and we look at the date open column, you can see that I've ordered that from earliest to latest, and all of the dates fall between the 4th of April 2022 up until the 10th of June 2022. So what I'm going to do now is use a where clause on the date opened column, and we're going to get all of the restaurants that were opened after the 1st of May 2022. So let's go back to the Execute SQL tab, and I'm going to remove the restaurant type clause in the where statement. And this time we're going to look at the date opened column, and we're going to get all of the restaurants that were opened after the 1st of May 2022. If we execute this statement, we get back these results, and you can see all of the date opened values are greater than that cutoff date. So this shows you two things. First of all, we can perform greater than operations, and as you can imagine, we can also do greater than or equal to and less than operations. And also we can perform these conditional filters over dates as well. So we have a date column that has the data type of date, and we can perform a greater than or equal to on that column, and we get back results. So we can very easily look at data between two dates, for example. These database systems are well equipped to deal with dates and to do this kind of filtering based on different dates. Now, so far we've been asking for every single column in the results of our query, and we do that using the star wildcard operator. But what if we only wanted a subset of columns? For example, we might only want the name of the restaurant. What we can do is, in our select statement, we can explicitly specify which columns we need. For example, we could select the name from the restaurant table, and we're only going to get the names for restaurants that were opened after this date. So let's execute that query, and we only get back that one column now for the name. And if we want more than one column but not all columns, we can separate them with commas. For example, this statement here, where we select the name, the latitude and the longitude from the table, and we're going to get back this data here where we have 3 columns, the 3 that we've selected, as well as all the rows that match this condition. So that's how to filter using a where clause. We're going to do a few more expressions and then we're going to finish this video. If we go back to the database structure, we have another table here, and that's for sales in the restaurant. This is an imaginary table that tracks different sales that have occurred, and you can see we have another foreign key here to the restaurant ID, and we have the sales date time whenever the sale occurred, and also an income column that tracks how much was made during that sale. So what we're going to do is we're going to go to the Execute SQL tab, and I'm going to remove all of this here, and what we're going to do is we're going to perform an aggregation in this select statement, and we're going to sum up all of the income from all of the sales in this table. And we can use the aggregation function sum in order to do that, and we provide a column name. In our case it's going to be income, and we select that from the core_sale table. If we execute that, we get back one number, and that's 5,050, and that's the sum of all of the incomes made from sales that exist in that table. So this is an example of an aggregation function in a database. There are different aggregation functions. For example, the average function will calculate the average income over all of the sales in the table, and we get back a value of 50.5 for that. Now if we go back to the data in this sale table, you can see that there are different restaurants represented. So we have a foreign key to all of the restaurants in our restaurant table, and each restaurant has many sales. What if we wanted to get the sum of all of the sales for each restaurant in the data? What we did before with this sum function here is we got a global sum of all of the sales no matter what the restaurant was. But what if we wanted to say, well, I want to get the sum for each restaurant in the data and then sum it up for that restaurant? So what we can do is we can write a different statement here. As well as just getting the income in the select expression, I'm also going to fetch the restaurant ID. So I'm going to copy that into this select expression here. So you can see we have a restaurant ID and we're selecting the sum of the income, but what we need to do is we need to group these values by the restaurant ID in order to get the sum for each restaurant in the data. So I'm going to group these by the restaurant ID, and we're going to execute this query, and you can see in the results that for each restaurant we have a sum of the income, and you can see the sum of all of the sales for each restaurant in our system. So this is how we can group by certain values based on the primary key, in this case the ID, and for each grouping we can perform some sort of aggregation. In this case we have a sum of the income for each restaurant in the data. And you can see in the output below we have a column header of sum income. We can use what's called an alias to give that a particular name. So I'm going to use an alias here, and we do that using the as keyword in SQL. And we can give that sum of the income an alias of total income, and that will then display that in the column below as you see in this column here. So in this query we're taking all of the rows in the sale table, we're grouping them by the restaurant ID, and then for each grouping, for each set of values associated with each restaurant, we're then summing up all the incomes and we get the outputs below, and we can quite clearly see for each restaurant how much money they've made by using a query like this. And you might be interested to see which restaurant has made the most money out of these restaurants. So what you can actually do here is chain an order by expression in SQL, and you can order by a particular column in your output. Now what I'm going to do is I'm going to use this total income column here, but because we're referring to a column name that actually has a space, I'm going to use these forward ticks here, and we can refer to that column name and then execute the query. And as you can see, this is ordered from the restaurant that made the least amount of money up to the restaurant that made the most amount of money. If you're interested in getting the values in the other order, where the restaurant that made the most amount of money comes first, you can use the descending parameter here after the order by, and that will then put the highest value first, and the values below that will be descending. So when you're ordering by a particular column, you use the order by expression and then the name of the column, and then if you need to order it in descending order, you can use this keyword here. Now let's finish this video by demonstrating how to do a join based on the foreign key that's available in one table. I'm going to remove this statement here. And what we're going to do is we're going to join the restaurant table with the sale table so that we can see all of the data for each sale, including the restaurant's name. Remember, the restaurant data, such as the name, that lives in the restaurant table, whereas the sale data, such as the income, is in the sale table. So we need to join that data based on the foreign key. So if we go to the sale table, it's this restaurant ID in the sale table that we're going to use in order to join the data in this table to the data in the parent table, which is the restaurant table. So let's go back to the Execute SQL tab, and we're going to select all from the core restaurant table to begin with. And then we're going to use an inner join keyword, and we're going to join with another table, and that other table is going to be the sale table. So we're doing an inner join between the restaurant and the sale table, and we need to specify how the join will occur. So we use the on expression for that, and we're going to join on the core restaurant's primary key, which is the ID column. We want to make the join when that ID column is equal to the sale table's restaurant ID, which remember is the foreign key to the restaurant's ID. So when the restaurant ID here is equal to the ID in the parent table, we're going to join and return all of the data. If we execute this query, we see what is returned below here. We get all the data in the restaurant table, which is everything up to this longitude, and then on the right we get the sale data associated with that, and you can see that the IDs match up here. We have the ID of the restaurant matching with the restaurant ID that's coming from the other table. So basically this is taking the two tables, and it's taking all of the columns in the two tables, and it's joining them together, and it's telling us everything we need to know about every sale in the system and which restaurant that sale is associated with. We could return this to clients as a report, and they'd be able to see exactly which restaurants are making which sales. Now we might not want all of the columns from the tables involved in this join. For example, we don't need two instances of the restaurant ID. There is a column in both tables for this ID, and in fact that's what we're using to join here, but we don't need to output that twice in the result set. So what we can do is, instead of using the select wildcard, we can explicitly specify the columns that we want. So I'm going to specify here the restaurant ID, the restaurant name, and the restaurant type. These all come from the restaurant table, but we also have the income, as you can see here, and that comes from the sale table. So if we execute this new query, we get back a subset of the columns, and we can see that for each restaurant we get back particular sales, and we can see the income from that sale as well. And this is done with a join. This data here lives in a different table from this data, but we're using a join on the ID column, the foreign key, in order to join the records together and show the data that we need. Now you can see the sales are kind of mixed up here. We can use an order by expression and order by the restaurant ID. So I'm going to chain an order by on this, and we can order these sales by the core restaurant's ID. And then when we re-execute this, we get back a more ordered data set on the left hand side. We can see that the IDs for the restaurant 32 are all one after the other. And we can see the incomes for that particular restaurant based on the data from the sale table. So that's a quick primer in some of the things you can do in SQL. There's a lot more to SQL than this, but that covers most of the basics that you need Now when we're using Django, we don't often need to write SQL explicitly. The Django ORM will abstract a lot of that away from us, but it is very handy as a back-end developer to know a little bit about SQL, and you can see some of the ways it's used in this video here. So thank you for watching. This has been the introduction to the Django ORM series. In the next video, we're going to cover how to define Django models, and we're going to go over migrations and different columns that we can use within our Django model classes. We're also going to learn how to use choices within Django applications to restrict the values that can be input into a column based on a selection of choices. And again, if you have any suggestions for the Django ORM series, please let me know in the comments. Otherwise, thank you for watching. Please like and subscribe if you've not done so already, and we'll see you in the next video.